Hello friends, let us see how to draw SFD, BMD and AFD, that is axial force diagram, bending moment diagram and shear force diagram for statically determinate rigid jointed plane frame. So the question is draw axial force diagram, shear force diagram and bending moment diagram for the given frame. A and B, they are the external hinges where D is an internal hinge. Now column AD carries 8 kN per meter load, whereas beam DC carries 20 kN per meter load. This is 4 meter, this is 6 meter and it is separated by distance 5 meter. So, to start with, let us assume HA from right to left. Now we know that bending moment at D is 0 because D is an internal hinge. Now the definition of bending moment provides us the flexibility of either considering part DA or considering part DCB for calculating bending moment at D. So assuming HA from right to left, let us calculate bending moment at D. So bending moment at D equal to 0 gives HA into 6, that is this HA into perpendicular distance 6 minus 8 into 6 into 6 by 2. This is plus because it is trying to open out at D, whereas this UDL is trying to close at D. So opening I take positive and closing I take negative. Therefore, the value of HA is 24 kN. Here, students, you have to note down that I assumed HA from right to left and the answer came out to be positive. That means my assumed direction is correct. Now, calculating other horizontal reaction at the other hinge B, that is HB, let me again assume it as right to left. So when I assume it HB from right to left, so summation of Fx equal to 0 gives my sign convention here is from left to right is positive. So it becomes minus 24 plus 8 into 6, that is this is going from left to right, minus HB, that whole equated to 0. When again I do solve this equation, I get HB is equal to 24 kN. Again, you have to note down here that HB I assumed as from right to left and the answer came out to be positive. That means my assumed direction is correct. That means I can finalize this as 24 kN and 24 kN. Total it is 48. So 24 plus 24, it is 48 to this side and 8 into 6, that is 48 to this side. So that means you are correct. Now to calculate reactions VA and VB, let us assume VB upwards. Now I will take summation of MA with clockwise positive equal to 0. So what it gives me? That gives me VB into minus 5 minus 24 into 2 plus 20 into 5 by 2 plus 8 into 6 by 2 equal to 0. So when I solve, VB equal to 69.20 kN. Again, you have to note down here that VB I assumed upwards and the answer came out to be positive. So it's correct. I mean assumed direction is correct. Now summation of FO equal to 0 gives VA plus VB, that is VA plus 69.2 minus 20 into 5 equal to 0. Therefore VA is 30.8 kN. Here the answer again came out to be positive. So the assumed direction of VA is correct. Now let us start drawing the free body diagram of part AD. So I have drawn AD separately. I have shown 8 kN per meter acting for 6 meter. Here it is 24 kN, that is HA, whereas VA is 30.8 kN. Now again, if I see this 8 into 6 is 48 going from left to right, and here it is 24. So to balance that, I need one more 24 kN here at D. Therefore this 24 kN and this 24 kN, it is 48 kN in this side going this side, whereas this 8 kN to 6 going 48 going this side. So now it is balanced. Again we know that VA is 30.8 kN. Again for the equilibrium of part AD, this 30.8 kN must be in a downward direction. Now starting with axial force diagram, the axial force is 30.8 kilonewton compressive in nature, which is trying to compress the column AD. Therefore, compressive nature I take negative. So, draw AD and then all the negative quantities I show inside of the frame. Inside means right side. So, 30.8, 30.8, same, I join it with a straight line, negative. So, that is the axial force diagram, compressive. Now, coming to shear force diagram, simple way, always stand inside the frame and look towards the part of whose you want to draw the SFD. So, automatically this becomes your right and this becomes your left. Again, due to 24 kilonewton at A, left is going up or left is going out, and that I take it as positive and I draw it outside the frame. So, it is 24 kilonewton, I have drawn outside and I have shown positive. Again, coming to D, because of 24 kilonewton, right is going up, right is going up. So, right up we take negative. So, since positive I have shown this side, negative I will show this side, and that is 24 kilonewton. Now, I will join it to the inclined straight line. So, this is positive and this is negative. Obviously, this is 24 and this is 24, and therefore, the shear force diagram will cross this line AD at the center, that is 3 meter from here and 3 meter from here. Now, we know that where the shear force becomes 0, bending moment becomes maximum, and therefore, bending moment at x, we can directly use the formula for simply supported beam, because coincidentally both these forces are same. So, it is a standard case of a simply supported beam loaded with a uniformly distributed load throughout, and therefore, we know that the bending moment at the center is WL square by 8, that is 8 into 6 square by 8, that becomes 36 kilonewton meter. Already we know that MA is 0, bending moment at A, that is extreme simply supported end, and MD is also 0 because it is an internal hinge, and therefore, I draw the bending moment diagram as a parabola and I show it as positive. Now, coming to free body diagram of DC. So, I will draw free body diagram of DC. Now, you know that here for part AD, this force was 30.8 kilonewton in the downward direction. Therefore, again for the equilibrium of particle D in the vertical direction, you have to reverse the direction of that force. So, 30.8 kilonewton in the upward direction. Again, coming to this 24 kilonewton at D going towards left, again when I consider for part DC, you just reverse that direction, 24 kilonewton going towards left for the horizontal equilibrium of particle D. Now, again if this is 24, this must be 24. Again, this 20 into 5 is 100 kilonewton going in the downward direction. Already here it is 30.8, so 100 minus 30.8, the remaining internal reactive force is 69.2 kilonewton going in upward direction. Again, we know that there is no bending moment at D, so symbolically I have shown that bending moment is 0. You should not get confused with this direction. Only to indicate that bending moment is 0, I have just shown as if it is sagging, and I have written it 0. So, it clearly tells that there is no bending moment at D, owing to the fact that D is an internal hinge. Now, we know that this 24 kilonewton is creating the axial compression. So, compression means I show inside the frame, that means below 24. So, this is the axial force diagram, compressive in nature, I take it as negative. Now, coming to shear force diagram, the shear force at D is 30.8 kilonewton. Because of that, left is going up, so it is positive. Shear force at C is 69.2 kilonewton, and because of that, the right is going up. Right up is negative, so I show it below. Now, since it is a UDL, I will join it as the inclined straight line. So, it is plus and minus. Again, I know that shear force is becoming 0 at a distance x from the D. I know that at x the bending moment is maximum. Therefore, how to find x? Very simple. You just consider section xx here at a distance x from D and equate here shear force to 0. Now, the definition of shear force is either you consider one part or the other part. Let me consider part dx or xt. And shear force, let us calculate shear force here. So shear force here is 30.8 minus 20x, that is written here, and that is to be equated to 0. So x works out to be 1.54 meter from D. So we have got the value of x as 1.54 meter from D. So now we know very certainly that the bending moment is going to be maximum at a distance of 1.54 meter from D. Now moving, bending moment will be maximum at x. Therefore, again to calculate bending moment at x, consider part dx. I will take bending moment. The bending moment will become 30.8 into 1.54 minus 20 into 1.54 into 1.54 by 2. So you can see here 30.8 into 1.54 minus 20 into 1.54 into 1.54 by 2, because x is 1.54. So when I do solve, mx, that is m maximum, works out to be 23.716 kilonewton meter, which is positive. Now coming to bending moment at C, the bending moment at C can be calculated as 30.8 into 5 minus 20 into 5 into 5 by 2. Because the definition of bending moment at C is either you can consider part CDA or you can consider part CB. I have considered part CDA, and the effect of AD at D is already 0. There is no bending moment getting transferred from AD to D, since it is an internal hinge, it is not a rigid joint. So when I do solve, MC works out to be minus 96 kilonewton meter. Alternatively, even you can prove it by considering part CD. So when you consider part CD, it is 24 kilonewton, that is HB, this is 4 meter, this is 69.2. So when you take bending moment at C, it becomes 24 into 4, and it is negative because 24 is trying to close, and closing we take negative. So again here the answer works out to be same. So either way you can go, whatever is convenient. And now I will draw the bending moment CD, a straight line, and here at 1.54 meter from D it is plus 23.716 kilonewton meter, and at C it is 96. So join it with the parabola, it is negative and positive. Finally, to conclude, let me draw free body diagram of part CB, that is column CB. Already I have seen that this is column CB. Now it is very easy because it is free of any loading. So to draw the free body diagram, again I know here reaction VB is 69.2, HB is 24. So obviously since it is free of any load, here it will be 24 in this direction, so that this gets cancelled, these two things get cancelled, and 69.2 in the upward direction, therefore 69.2 in the downward direction. Now when I do draw axial force diagram, since it is creating compression, so I will show it inside the frame, therefore it is CB, and I have shown inside the frame, that is axial force diagram. Now coming to shear force diagram, always it is better to imagine that you are standing inside, and this is your left, this is your right. Because of 24, your left is going up, so left up is positive 24. Because of this 24, right is going down, right down is also positive, so that is also outside. I have joined it to the straight line plus. Alternatively, you can say that between C and B there is no any load, so shear force will remain same. So either way the answer will be same, and there is no necessary to go for calculating bending moment at C, because already you know that from the previous step that bending moment at C is minus 96 kilonewton meter, and since B is an extremely simply supported end, so bending moment at B is 0. You join it with inclined straight line, negative, so that completes the problem. Thank you very much.